Hello, Matrix, and welcome again. Today we are looking at optimization. So optimization is when you find the maximum or minimum of a function. So optimization has a lot of applications in industry. For example, if you were wanting to maximize the profit of a company, you could get the profit function and you would optimize it by finding the derivative and then making that equal to 0, and then you could find the profit maximum. And if you were, say, looking at the costs of a company and wanting to find the minimum costs, you could then find the minimum by doing the same thing, making the derivative equal to 0. So optimization is very, very handy, and you'll use it a lot if you go to university and study finance, or if you do physics, you'll use optimization there as well. So let's look at optimization, and what I want to do is use an example from a past paper, which is also a cubic function, because we did cubic functions last time. So I thought what we would do here is revise cubic functions and be introduced to optimization. And then the next lesson, we'll do some more optimization. So let's look at the steps for optimization. So I've broken this down into 3 easy steps. The first one is to find the function in terms of one variable. So for example, f of x equals x squared plus x plus 2. There's one variable, which the variable is x. In this question, we've got h of t equals t, blah, 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 but the t is one variable. So in this first one, we've already only got one variable. So it's already, step 1 has been done for us. Now the second step is to find the derivative. And then the third step is to make that derivative equal to 0. That will tell you the maximum or the minimum. And then we then will know, we can then substitute that into the original to find what the minimum value is. So what I want to do here is, even though it's not asked in the question, this it says after, we've got a cubic graph, but let's read it first. After flying a short distance, an insect comes to rest on a wall. Thereafter, the insect starts crawling on the wall. The path that the insect crawled can be described by the following function, where h is the height and t is time. Okay, so sometimes you can get bogged down with the mathematics of these questions, but rather just think of it logically. What they're saying here is that the height, h is basically height, equals, and then it's a function of t. So t is time. So height equals a time is a time function. So let's now look at this function. So I'm going to write down this function h of t. And when we times it out, we're going to get a cubic function. So I want to do this because I'd like to just spend one more of these sessions looking at cubic graphs, because it's going to come up and it's not necessarily that easy. So even though we've gone over a couple, I think one more won't hurt. So what I'm going to do is I'm going to times this out. And so we get minus t 2t cubed plus 3t squared minus 6t. Then I times by this one now, these 3, so 6 times the other 3. So it's then plus 12t squared minus 18t plus 36. And so the t squared, so it's minus 2t cubed plus 15t squared minus 24t plus 36. Okay, so this is a cubic function. And when we want to look at the turning points of a cubic function, we find the derivative. So we could do that. now, but I'm going to do that in the final one because 8.3 asks us to determine the height, maximum height. And so maximum is when we find the derivative and make that equal to 0. So I'd just like to look at this cubic function quickly, because this cubic function has roots. So in other words, if we make the cubic function equal to 0, we can find the roots. Now, we already know, because we factorized earlier, that t minus 6, t equals 6, is one of the roots. So if I was to draw the function, I know that one of the roots is t equals 6. And of course, time can't go backwards. So none of the values where t is below 0 will count. Okay, so now what I'd like to do is just put this function into the silver calculator to see how many roots we would get. And so I'm going to put it into the calculator. So what I do is I say on mode, and I'm going to go to the equation mode, and I'm looking for the equation of a cubic function, which is 4. Now, a is minus 2. B is the next one, and that's is 15, because it's 15t squared. Then C is minus 24, and D is 36, equals. Now I get that X is this first one, 6, 1. Now this tells me I means imaginary, and X2 is also imaginary. So if I was to try and factorize the second bracket here, I'll just mark this in green. This second bracket here does not factorize. So what I'm saying is I don't have roots. So there's a couple of things we know. Now, one of them is that plus 36 is the y-intercept. And so at 36, it enters the graph. Now, we don't know the roots. That's not that important, but it could either look like this, and we have a root at 6. So it could look like this, or it could look like this. We're not sure. But what we do know at the moment is that there is only one root. Okay, so that's cubic functions, because in the last lesson we looked at cubic functions which only had one root. So this is an example, and I didn't show you last time that you could use your silver calculator to test, and you could actually see that there's only one root. So yeah, if you want to look at just getting these silver calculators, they are very handy to check things. You don't want to use them without doing the working, because then obviously the examiner is going to know you used your calculator and then not going to get the marks, because they will know that you could simply have just put it in the calculator to get the answer. Okay, so now that I've at least shown the cubic function, I could derive this function. I'm not going to do that yet. And that would tell me the turning points, which would be our maximum and minimum value. So I'm just going to give an example. If these were the turning points here, you could maybe have a maximum there and a minimum there. Okay. Now, the first question says, at what height does the insect start to crawl? Okay, so here's where you need to think logically. When does the insect start to crawl? Well, it starts to crawl at the beginning, which is when time is 0. So all we need to do is we just need to say h of 0 equals. And I could put this function in here, the t minus 6, and I'm going to do that because I wouldn't have actually necessarily multiplied the function out. So I would say 0 minus 6 times negative, and it would be 2 times 0 squared plus 3 times 0 minus 6. And of course, I end up this is all just minus 6, and that's minus 6. Minus 6 times minus 6 is 36. So it's 36 centimeters. Well, I can see that because on the graph which I just drew here, it starts at 36. So the height starts at 36 meters. Okay, now the second one says, how many times does the insect reach the floor? Well, it reaches the floor when the height is 0. So what I did here was I tested, and I saw that I only got one root. So it only factorizes, when you factorize, I only get one answer. So 8.2, I know the answer is 1, and it's at 6, but I first have to just show it. So I say t minus 6, therefore t equals 6. And now negative 2t squared plus 3t. Now, if I didn't use my calculator to check that I didn't have roots, I could try and factorize this. It would take a long time, but I wouldn't get it. But now that I know that it doesn't factorize, I can simply just show my delta, which shows the nature of the roots. And remember, delta is equal to negative b minus b squared minus 4ac. Now remember, when we do our quadratic formula, that you end up with this square root b squared minus 4ac in the quadratic formula, and you know that if this is negative, you cannot find the square root of a negative, and so it's not real. So I'm simply going to put in b squared and show that it's negative, and I can say b is 3 minus 4a is minus 2, and c is minus 6, and so 4 times 2 times 6 is 48, and so I end up with minus 48 plus 9, so it's minus 39. Therefore, non-real roots, and so I can say once. How many times? Once. Okay, now the second bit is the optimization part. So often the first two questions are kind of just functions-based questions. They're not asking you to find the derivative. When in doubt, find the derivative on these optimization questions. So sometimes you might not know what's going on, but you know that if you have to find the maximum and the minimum, you're going to need to find the derivative at some point. So even if you don't know what's going on, find the derivative, make it equal to 0, because at least then you will get marks. So 8.3, determine the maximum height. So remember, find the derivative. Okay, so I've already solved for h of t. So I'm going to say h dash of t. And here I would have to times it out like I've done at the top. So this would be part of 8.3 here at the top. And then I find the derivative of this value, which is 2 times minus 3 is minus 6t, and I take 1 off the 3 to make it t squared. 2 times 3 is 6t, and then the derivative of minus 6t is, oh, wait, it's at the bottom. I was doing the top one. Yeah, 6t squared, and then 15 times 2 is 30t minus 24. Now I make this equal to 0, let derivative equal to 0, so I make it equal to 0. I can divide through by minus 6, so I get t squared minus 5t plus 4 equals 0, and so the derivative of t equals, let me factorize it first. T minus 4 t minus 1 equals 0. Therefore, t equals 4 and t equals 1. Now, I have to then put those into the original equation and see which one is the highest. So I'm going to do that now. I've got my silver calculator here. Okay, and when I've substituted into the original, I'm actually going to put it into the one that I was given in the question, the t minus 6 minus 2t squared plus 3t minus 6. The reason I'm going to do that is just in case I made a careless error in my multiplying out. This answer will still be correct because I'm using the original answer, the original equation. So I'm substituting 4 first into this t minus 6 minus 2t squared plus 3 times t, we're going to use this 4, and then minus 6, close the brackets, and we see what we get, equals 52. Okay, so the first answer we got was 52. Let's see if we get a higher one when it's 1. Okay, we get 25. So we know that the maximum is the one that we get 52 with. Okay, so now what we can do is we can put that in. Therefore, h of 4 equals 52. So the maximum height is 52 centimeters. Okay, now one of the things about this, so we've got the answer. So I just want to talk about this question a little bit now that we've kind of figured everything out. So 8.3, the maximum height was 52 centimeters. Okay, now let's look at this graph. We had a maximum at 1. Well, not a maximum, we had a value at 1. And we had another value at 4, a maximum value. So it hits a maximum at 4, and then begins to come down. And we have another turning point at 1, which is now our local minimum. Our absolute minimum is obviously the negative infinity. But of course, we're just worried about the turning point here, this maximum here. Now this was a local minimum, local meaning it's smaller than the numbers either side of it. In other words, the bottom. So that's what the function would look like over here. I'll do it in blue so that you know which one I'm talking about. So it hits at 36, the insect starts to call it 36, goes down, then comes back up, and then goes down again. Okay, now I just want to look at this negative 2t cubed to investigate this cubic function here. Because here is an opportunity to relook at how we get the shape of a cubic function. So I'm going to do it just on the side here in red. Okay, so what I like to do is I like to look at the extremes. So say what if t went all the way to say 1 million? So if you had 1 million cubed, that would be just a huge number, much bigger than all of the other numbers which are squares and t. So I look at where it's cubed because that's the one that's going to determine the shape of the graph. So what it tends to as x goes to infinity, or in this case, t goes to infinity. So when it's cubed, t goes all the way to infinity. When t is positive, it goes all the way towards infinity, but it's a negative. So it actually goes towards negative infinity. And let's say that t was, say, minus infinity. Well, minus infinity cubed will stay minus infinity, but there was a minus 2 in front, so it became a positive. And so we have this situation where it is going like this. Okay, because our cubic functions kind of always look like this. Okay, but now this one just didn't happen to have real roots. So this function only had one root. And so that's how we got this shape here. But if you weren't sure, you could do this without understanding it. But if you just look at this function that I'm now circling in red, sorry, the one below it is the simplified one. This red function, you have an idea of what it looks like if you understand cubic graphs. So if you want to go back and look at cubic graphs again, there's 2 or 3 videos that I did before this that you can check out. I'm probably not going to be doing cubic graphs again during calculus. This was just to introduce you to optimization, to finish off our work we did with cubic graphs. In the next next video, we are going to do optimization again, and we'll look at a different example. But yeah, hopefully this helped you. If it did, find the subscribe and like button down below because you're going to get notifications on when I do another video. And these videos will help you with getting a very, very good matric. As long as you do the work, watch the videos, practice your past exams, you will be fine. And yeah, I will see you in the next video.